For the delay, but one of your classmates figured out that if you, rather than laptop, you choose DVD, then we get the image on the screen. So let's see how it works out, and somebody might be coming to take a look at this. But anyway, I apologize, and I don't know what is going on here. But let's, today, in fact, I just want to just ease back into classes again. And so I was just going to go over the course info and then show some videos, really, of fluid in motion. But we can just at least go over the course info and then really start lecture on Wednesday. So I hope everyone was able to access the Canvas site. And so what I have here is the syllabus. And if you took MAE 11 from me last quarter, a lot of this will be familiar. I'm rather consistent. But anyway, let's just go through it. So we have our lectures Monday, Wednesday, Friday here in this room. And Friday is a regular lecture for the 4th hour at 12 over in York. So we'll all be getting a workout on Fridays. And then I am podcasting the lectures, and we'll post in Media Gallery. And there might be, I don't know for sure, but there might be sometimes when I need to do the lecture on Zoom. And so if so, just pay attention to the announcement, and it will be scheduled in Zoom. I'm Keiko Nomura, the instructor for this course. The best way to contact me is email, subject line MAE 101A, so I know it's important. Now these are my proposed office hours through Zoom: Tuesdays 2 to 2:50, Thursdays 11 to 11:50, or by appointment. And then the TA is my grad student Ben Keaton, who's been TAing 101A before, so he's excellent. Here is his email. He's going to have office hours on Monday, 12 to 12:50, and then a discussion session on Wednesdays, that time, both by Zoom. Just to confirm, any of you who would like to, and the TA sessions are optional, but is anybody not able to attend any of my office hours or the TA sessions? Okay, and then I can accommodate by appointment as well, so good, we've got everyone covered. Okay, so the course description, so I think this is the catalog description, the prereqs for that, which you've all met, but we're basically going to cover those subjects. And you can always refer to the MAE standard course syllabi for any of your MAE classes at this link. The textbook is Fundamentals of Fluid Mechanics by Munson, Young, Okishi. Actually, they're the original authors. These guys are listed as the current authors, and then they call the book Munson, Young, and Okishi's Fundamentals of Fluid Mechanics. But it's been around for quite some time, and most of the instructors of fluid mechanics here. So, but I do have a question. Thank you so much for coming. So we finally got to work when we chose the DVD. All right, so apparently it was rewired to the DVD connection to make this work. So, where was I? Okay, so the textbook, a required textbook, we're using the 8th edition this year, also in the other 101A, B sections. And I'm not quite sure about the status, because usually I get an email. Have you received an email from the bookstore indicating the inclusive access? So you should be, after this class, I'll contact them and find out what the status is. Okay. But anyway, I think instructors of the fluid mechanics really like the Munson textbook. I particularly like the explanation of the physics. And it's a good balance of mathematical rigor and description of physics. So I hope you can, listen to lectures and then read the textbook as further discussion of the topics. Okay? As I mentioned to you, I will find out what the status of the textbook is. If you have an older version, that should be okay. In this class, I believe from time to time, I may assign homework problems from the textbook, because there are certain problems, for example, there are certain problems where the flow system is rather complex, involved, and so they, in the textbook, have some image diagram. And so sometimes I may use the 8th edition the chapter textbook problems, but otherwise all the other information should be fine from using a different edition. Okay, homework, I will assign basically weekly homework for you to do and learn from. And they will be submitted, you will submit in Gradescope like you did in MAE 11 at a specified due date and time, and we don't accept any late homework. The homework must follow specific requirements. So let me see if I can access this. And okay, it should come up. All right, so please take a look at this, but it should be pretty straightforward and similar to that in MAE 11. Very important that it's clear and legible. It may be obvious, but sometimes we do find homework that is done, for example, on thin paper, both sides, and it bleeds through. Or in any case, if it's not legible, we can't grade it. One single PDF file, okay? And homework problems should be, like, you shouldn't have two separate problems on one page. So a new problem, start a new page. And then we won't have any issues in Gradescope, but I think you should all know that by now. So please take a look carefully at this. And then a standard format. So use this or something similar to present your work, the solution to the problem, and it needs to just follow some basic format, not only to present to somebody else or you at a later time, but also it follows a standard problem-solving procedure. So some of this stuff is pretty clear, but I do want to point out the definition of a coordinate system. That's very important in fluid mechanics because we're dealing with now vector quantities like velocity or forces. So you always have to define them with respect to a coordinate system. So be sure to define that. But as we go along, I'll do example problems, and so you'll, if you don't already from taking MAE 11 with me, you'll know what I mean by this. But the first homework, which I'll assign sometime this week, probably do the following week, will be fairly simple problems from Chapter 1. And so you may not need all these components. But I think starting from Chapter 2, you should be able to follow this format. Okay, let's see why. Okay, so we've got... what is going on here? Okay, here we go. All right, grading. I don't know what happened there, but... so we'll have weekly homework. I'll drop the lowest. It'll be worth 12% of your overall grade. We'll have 2 midterm exams, each worth 24%, and the final exam cumulative, but with emphasis on the last topic. Well, actually, I should say cumulative. Scratch that emphasis on the last topic. 40%. And then there's asterisk on these. So as I did in MAE 11, I am going to give you this option. We're going to do the grading such that the overall exam score will be the maximum of Now, the final exam is cumulative. You're learning as we do the midterms, and so if all goes well, this is the default breakdown. But let's say the second midterm was not your day. Okay, so then we can put those points to the final exam and just have the midterm 1 and the final exam go towards the overall exam score. Or if the first midterm 1 you're caught off guard with this new subject, and then you've got midterm 2, okay, the midterm 1 points will go to the final exam score. And then we're just going to take the maximum. Okay, so that's what we did for MAE 11, and we're going to do that here for 101A. Okay, and then of course the academic integrity. So please look this over. Let me just take a moment to read this. All students are expected to know their responsibilities and uphold the standards of academic honesty and engineering professionalism. Students are, of course, encouraged to discuss amongst you the lecture and homework topics, and that certainly promotes learning. But however, each student must do and submit their own work on all homework assignments and exams, of course, right? And submitted work that is copied or taken from an unauthorized source, or performed using unauthorized resources, considered cheating, and then we'll have to report that to your college. But for some time now, I haven't had to do that, so I'm sure, I hope that won't happen this time. Please refer to the UCSD website for any details. If you're unsure of anything, please ask. And then, of course, as engineering students, you need to know what the Code of Ethics is for engineers, so there's a link to that. All right, so here's the tentative class schedule, and it is tentative. Okay, a lot of people forget that. They see the schedule of the midterms and they just assume that. But I will announce the date of the midterm at least 1 week beforehand so that you'll know. Okay, so this is tentative. And I think the way the subjects work, again, this is tentative. We may, because we've got holidays going this quarter, we may be off a little bit, but this is basically the proposed schedule and the topics. So we're going to go through the first 1, 2, 3, 4, 5, 6, 7 chapters of the textbook. And in 101A, you basically learn methods of analysis. Okay? As I'm going to explain, in general, fluid mechanics is really sort of a division of mechanics in general. And you've had like the statics and dynamics, systems that are not moving, and then systems that are moving, or objects that are moving. And so in fluid mechanics, we've got fluid statics. We're going to study fluid that is stationary. And then fluid dynamics, fluid in motion. And we're going to focus, of course, on fluid in motion. That's the most exciting and interesting. But I think fluid statics is very important, of course, for the application of fluid measurement. Pressure variation, for example, in the atmosphere, we have hydrostatic pressure distribution. And then if you have objects that are immersed in fluid, for example, objects that are underwater, then due to the fluid pressure, there is force acting on them, and we need to know how to evaluate those forces. But aside from that, as you'll find, when you describe fluid in motion, okay, we describe it in terms of a velocity and pressure distribution. And we're all familiar with velocity and pressure. Pressure we deal with, on a daily basis, perhaps, and we dealt with it in thermodynamics. Okay, pressure shows up in ideal gas equation of state. But I would say, and based on interacting with a lot of graduate students as well, pressure and understanding pressure and how it varies and the implication of it can be challenging, okay? And there's subtleties. For example, there's various types of pressure. There's hydrostatic pressure, there's static pressure, there's stagnation pressure, there's dynamic pressure, and it gets kind of intense. Something that seems rather simple than common, there's some subtle details that we need to learn, okay? And so understanding and knowing the pressure distribution is the key, for example, to determining the drag force on an object, okay? Or lift force. All you aerospace engineers, lift is essential, right? And it comes from knowing the pressure distribution over an object. And if we know that, then we can integrate and determine the net force. So pressure in a moving fluid is complex. And so first, if you study pressure distribution in a stationary or static fluid, okay, that's the first step. So it's another important sort of step in understanding fluid dynamics and starting to understand pressure and the associated force of some surface in that fluid with that pressure distribution. Okay, but that should take us maybe a week and a half, and then we're going to move on to fluid dynamics. So the textbook first introduces some elementary fluid dynamics, and when we describe fluid motion, we're going to consider the basic governing equations, which are conservation mass and conservation momentum. Conservation momentum is essentially Newton's second law, which you should be familiar with. I mean, how do you get something to move? You apply some force. And so that's really sort of the basis of fluid mechanics, fluid dynamics. That force might be associated with pressure, a net pressure difference, or gravity. If I had my cup of coffee still and I tilt it, and the fluid's going to run out and start moving due to the force of gravity. And then there is a very simplified equation describing flows in a very idealistic, under idealistic conditions called Bernoulli equation, the most used and the most abused equation in fluid mechanics. You'll love it, but you may use it under circumstances that it's not valid, but we're going to go over that. So some basic, simple fluid dynamics. Then we're going to get more involved and consider how you describe fluid motion. And then the first main method of analysis is referred to as control volume analysis or integral analysis. We did that in MAE 11, so it's sort of a more overall, simpler form of conservation mass and momentum. And then we're going to look into applications. And I think the first midterm then will go over fluid statics and control volume analysis. So that's when the governing equations are in integral form. You just integrate over your entire system or flow and get the overall effect. Then we're going to study differential analysis. Differential analysis, we look and use the differential form of the governing equations, so they are differential equations, which you know how to solve if they are simple enough. And they will give you the details of a flow, okay? And it's ultimately important to understand the details. And so these are sort of the most general form of the governing equations. And so we're going to study them in quite, detail. So differential analysis for a few weeks. And then finally, the third method of analysis is referred to as dimensional analysis. And this is a little more maybe abstract because it's not based on, well, I shouldn't say that, but it's not necessarily solving mathematical equations. But it's the basis of characterizing and describing flow behavior, also testing. So you may all know that if you want to determine a drag force off, say, an aircraft, okay? So you might have a design of an aircraft Now, if you want to determine the drag and lift force, okay, are you going to move that aircraft, try to build a wind tunnel large enough to fit an entire aircraft so you can measure the force acting on it? Well, no, of course, you can't do that. So you have to use scale models, right? You build a small scale model that fits in a wind tunnel, okay, and then you do measurements on that, and based on those measurements, you can predict the full scale behavior and forces. So how can that be done? Okay, how can you take the small scale model to predict the actual prototype behavior? So it's all based on dimensional analysis. Okay? Dimensional analysis is so extremely powerful and essential to do flow analysis. So in 101A, the main objective is to learn the methods of analysis, 3 methods of analysis: integral analysis, differential analysis, dimensional analysis. Okay? And then, as you'll find out if you continue to 101B, you apply the methods of analysis to analyze flows in various applications. And but we'll still, look at applications, of course, here, but that's sort of how 101A and 101B are set up. And then in 101B, the last, it's a little over a third of the course, we're going to do high-speed compressible flow, where the fluid is moving so fast that pressure variations are significant, such that it's going to affect the density and the temperature. And once you start changing the density and temperature, you have to bring in conservation of energy and equation of state, the thermodynamic state changes, and we have to bring in our thermodynamics. So if you think that MAE 11 is done, you'll never have to do another PV or TS diagram. We're going to have to bring back the TS diagrams and all that stuff, enthalpy, entropy, in 101B, high-speed flows. But it's extremely interesting because things that happen in flows that we experience common day, slow enough that we can assume that the density remains constant, like if I just blow air. Once we have compressible flow, and not only pressure and velocity are changing, but density and temperature, then things can happen that you may not expect, or different phenomena occur, such as shock waves. So it's very interesting, but that's 101B. So I think I've spoken enough about the course info. Any questions on course info? Yes?
The TA discussion that you had said that's kind of like an office hour, would that be recorded?
No. I think when we record things, the TA sessions are really for you to be able to go and freely ask questions. And I think the problem is some students hesitate if they know it's recorded, and they hesitate even more to talk and ask and speak up. For example, if there's interest in my giving review sessions through like a Zoom, I'll certainly record that, okay? But we'll see how it goes, okay? And if there's really a strong, an urgent desire for that, I'll talk to the TA and he might consider, okay? All right, any other questions on course info? Yes?
Will you be posting like lecture slides before class?
Well, I could, but I did that in MAE 11, and there was I was sort of surprised, there was a lot of criticism and negative comments. Because I guess when you post notes, and I had indicated these are lecture notes, these are the notes that I did when we did Zoom lectures during the pandemic. In fact, actually, when I taught 101A last year, remember how we all came back during the fall quarter, then we had to all go home, the winter quarter? Oh, that was so terrible. But so I taught 101A by Zoom last year, winter quarter. So I could post those lecture notes, but I think what people then assume is that they would be comprehensive and they could just read through them and understand everything. But that's the textbook. If you miss something in lecture, it'll be in the textbook. Okay, so you can read through the textbook. But if there's a strong desire for me to post lecture notes, I can. Do you guys want me to post those lecture notes that they're notes just like stuff that I write on the board, but they're not filled in with discussion? Do you want me to post them ahead of time? Because I'm certainly happy to. But I just don't want people to feel, like upset because it's not a full text explanation, but it's to follow the class, along class. Okay, I think it's time. I'm sorry I could not, show any videos, but I'll do that Wednesday, and we'll get started with lecture on Wednesday. Really apologize with the technical issue today.